Okay, the first thing I think we're going to start with in trigonometry is to start with our cast diagram. So we know this is our 0-degree line. We're going up to 90. Then we go on to 180 and 270. And then we return to 360. So we know in the first quadrant, we have theta, which represents an acute angle. Then we're going to quadrant 2, and we're going to refer to that as 180 minus theta. In quadrant 3, that's our 180 plus theta. And in quadrant 4, we reference that as 360 minus theta. And we know from the cast diagram, and those of you remember, so we start with CAST, which means in quadrant 1, everything is positive. In quadrant 2, only S, which is sine, is positive. Quadrant 3, tan is positive. And quadrant 4, where we see that C standing for cos to be positive. Now, what you also need to know is that we have co-ratios that exist. In quadrant 1, we can also refer that to a 90 minus theta using our co-ratios. And this one would be a 90 plus theta. So a simple way to look at a trig function, if we have as such. So if we have something called sine of 180 plus theta, the first question we ask ourselves is, in which quadrant is this? And that 180 plus theta is in quadrant 3. And if you look in quadrant 3, only tan is positive. So in quadrant 3, we know sine will be negative. And we're using reduction formula, sine of the acute angle called theta. So that's a simple way we can use reduction formula. But if we look at something using 90 minus theta, if we have cos of 90 minus theta, so we know 90 minus theta is in quadrant 1. And in quadrant 1, cos is positive. We don't have to write the sign. And whenever we use a 90 minus or 90 plus, we use the complementary angles. So the complement of cos is sine theta. If it was sine, then the complement of sine is cos. So we're using what we call here, I'm sure you've done this in class, which is called the co-ratios. So our cast diagram is very important to us. And then I want you to make a note of this, because I'm going to refer to this cast diagram quite often during the lesson. So we must be able to quickly come back and look at what it looks like in the cast diagram. Moving on, I want to just touch on some formulas before we start with some past paper questions. So important formulas that we've learned in grade 11 is that your sine squared theta plus your cos squared theta is equal to 1. But from here, we can create two sub-formulas. So if we make sine squared the subject of the formula, we can say sine squared theta is equal to 1 minus cos squared theta. That means we took the cos on the other side, it becomes negative. And if we make cos squared theta the subject of the formula, we're going to get 1 minus sine squared theta. So we have one formula, but we have it broken down now into 3 parts. Then we have a very important formula. Whenever you're confused and you see tan theta, remember tan theta can be changed to sine theta over cos theta. So those are our important formulas that we're going to use in today's session. So I want you to make note of those formulas. Sine squared plus cos squared is 1 with the 2 sub-formulas there. And then tan theta is equal to sine theta over cos theta. So we're now going to move into some past paper questions and apply this. Okay, I've changed the document in terms of what I'm sharing. Are you seeing the document that has on the top their diagram?
Yes, sir. Yes, sir. We're seeing it, sir. I can see it, sir.
Okay, so we're going to look at some questions from here, and I'm going to show you how to approach these questions. I did give you a past paper. I did upload a past paper booklet. I'm not sure if your teachers have put it up on Teams for you guys. Yes or no?
Sir, I didn't get it, sir. I didn't get the paper, sir.
Oh, then that's a big problem, all right? It should have been uploaded to your Teams. So we're going to just survive without it for now. Is that okay with you?
No problem, sir.
All right, but
I'll just take screenshots of this one, sir.
Oh, okay. You guys are too smart. Okay, we look at the first one being a diagram question. It appeared in November 2018. You know, all the past papers are on the internet. They're on the Moodle. They're also on your Teams group. So you'll be able to pick up the memo. So I'm not too worried about the memo, but I just want to explain how to tackle questions like these. So if we look at the first question, it says in a diagram below, a point T is given to be x 15. So we know the we know the y value is 15. And it's a point, and it goes on to tell us that OT, and OT now would represent the radius of the circle. So if we're looking at the radius of the circle, it's given to be 17. And they give us another point P minus 2A. We know A represents Y. And then it goes on to say that K is a point on the positive x-axis and TOK is equal to theta. So this is called our diagram question. And in a diagram question, what we want to do is create a right angle triangle. So I'm going to drop a perpendicular down to the x-axis, giving me 90 degrees. So looking at point T as my reference, we have x and 15. So we don't know the x value. We're going to call it x. But we know the y value is 15. So we know if we look at a question like this, immediately we can use Pythagoras to find out x. So if we're trying to find x, we know x squared would be equal to 17 squared. That's your radius squared minus 15 squared. And then we would need a calculator. So I'm going to ask you guys to help me out. Type that on the calculator. Tell me what you get. So I know you're not sleeping.
$64, sir.
64. Well done. So we don't have to show any working. All right. You can write a reason if you want, Pythagoras. And then we find the square root. But remember, whenever you find the square root, it's going to be a plus minus the square root of 64. Now we have to make a decision. Where are we going to choose a plus or are we going to choose a minus? So because x is on the negative side of the x-axis, we are going to choose x to be minus 8. So that's how we find the value of x. So that's the first question. The second question wants us to find tan. Now, by definition, we know that tan is y over x. And looking at my diagram, my y value is 15. And I just found my x value, which is minus 8. And that gives me my tan to be 15 over minus 8. Going on to the next question. That's a cos of 180 minus theta. Now we know that 180 minus theta is actually sitting in quadrant 2. And in quadrant 2, cos is negative. So we're using our reduction formula. That'll give me a minus cos theta. And we know by definition, once again, that cos is actually x over r, which gives me a negative, but x is already negative 8 over my radius, was a 17, and a negative times a negative will give me a positive 8 over 17. Tell me, is my writing quite clear? Is it too small?
No, sir, it's clear, sir. It's clear, sir. I can see it.
If you're not seeing it well, you want me to change the color, let me know.
Okay, sir.
So the next question is to find sine squared. Now we remember whenever you square anything, it has to be positive. So that's our starting point. But by definition, sine is y over r. And if we look at our diagram, our y value is 15 over 17. And then we're going to square that. And you can use your calculator to find 15 over 17 squared. Would you like to help me out there? 15 squared should be 225. And 17 squared, do you have an answer for me? 289, is it?
Yes, sir. 0.77, sir.
Okay, we don't want to go to S to D because the question will say use your diagram and not a calculator.
Oh, okay, sir.
So did you get 17 squared to be 289?
Yes, sir.
All right, well done. So we move on to the next question. And the next question is changing our focus now to find A. So if we actually go to the diagram, you'll notice our A represents the y value of P. So I'm going to draw a perpendicular down. And then just put your mic off. I'm picking some background. So if we look at trying to find the value of A, so we're looking at the small triangle. As you can see, I just want to zoom there. And in the small triangle, according to this P value, we have the X value to be -2. And the Y value is A. Okay. Now, it looks like it's a very challenging question. But we know in terms of trigonometry, and if your definitions, the trig ratio that uses the X and Y. Now remember, we can't use R because we don't have R in the small triangle. So in the small triangle, we don't have R. So we want to use a ratio that has a Y and an X, and that will be tan. So we know that tan of theta is actually equal to, and if we look at a Y over X value, so remember tan is Y over X, and in the small triangle, the Y value is A, and the X value is -2. So we know that in a small triangle. But in the big triangle, we just worked out above that tan theta is actually 15 over -8. So your ratios are the same because the angle is the same. So we can take this now and equate it to 15 over -8. Because in the big triangle, tan theta is 15 over -8. And then by cross multiplying or finding an LCD, we're going to get -8a is equal to -30. And if we divide both sides by -8.
Sorry, sir. Why did you say we must equate them, sir?
Because we have the same angle theta referencing both triangles. So if you look at it, in the big triangle, if you look at the big triangle, what is tan theta in the big triangle? It's y. Remember, the y value in the big triangle is -8 over x. No, sorry, that's wrong. The y value in the big triangle is actually 15. Let me rub that out. So we're looking at the big triangle. So I just want to highlight the big triangle for you. So it's 15 over x, which is -8. But in the small triangle, we're saying that tan theta is equal to a over -2. So the ratios are the same because we are referencing the same theta. Sorry, the angle is the same. So tan theta is a over -2. We know that. But tan theta in the big triangle is 15 over -8. So we can now equate and say a over -2 is equal to 15 over -8. And then, so what I've done is divided both sides by -8, and therefore a now should be Negative over negative is positive, and then we can simplify 8 over 30. So we know 8 goes into 33 times. I'm trying not to use my calculator because they said use the diagram, but you can use your calculator to check. Remainder 6 over 8. And then you can simplify that to be 3 and 2 goes into 6. 3 times 3 3/4. Okay, so that is a simple diagram question that comes out in trigonometry, where you got to complete the triangle, find your third side using Pythagoras, and then you are using your definitions, where sine is y over r, or cos is x over r, or tan could be y over x. We're also using, you can see in some of the questions here, we've used a reduction formula. You could use co-ratios, etc. So we're now going to move on to some questions that involve reduction formula.
Oh, sorry, sir. For the section above, sir, when they say without the use of a calculator, so you must use the y, x, and the xr stuff, sir.
Yes, they're going to say, look at the question, with the aid of a diagram. So when they're talking about a diagram, you're using the triangle with its 3 sides. Does
Okay,
that make sense to you?
Yes, sir.
Okay, we're going on now. I just want to take variety, different types of questions. And what we can do in the end, if we still have time, we can come back. Okay, so I want to now move on to a different question. So if we look at this question, and this appeared in, on the top I have, if you want to turn to the page, is page 35, November 16. Neo has just joined us. Neo, can you please just keep your mic off because we're picking up background sounds. So if we look at this question, it tells us that sine 17 is equal to A. And they say without using a calculator. So without using the calculator, what you can use to help you is a diagram. Now we know 17 degrees is in quadrant 1 because it's an acute angle. All right, 17 degrees is in quadrant 1. Now remember, if they're giving us that sine of 17 is equal to A, so let's express A as a fraction. As a fraction, it's A over 1. And by definition, we know that sine means Y over R. Any questions there? Is that making sense to you? So we're going to take that and put into our diagram now. That the Y value according to this is A. So there's our Y value to be A. The R value is 1. There's our radius to be 1. And I'm just waiting to join, so more people to join us. So if we're looking at this question here, so we're now looking at a question that involves sine 17 is equal to A. I just want to repeat that for those that joined in late. We know if they're telling us that sine 17 is equal to A. So as a fraction, we can write A as A over 1. By definition, we know sine is Y over R. You see, it is very good practice if you want to survive in Trig for Monday's paper. Step 1, I would say, know your definition. And I just got people coming in, so they're coming in late, so I'm just trying to admit them at the same time. So remember, your definitions are crucial. Get it into your brain, memorize it. So we know if I have to write the definitions down, because I'm going to be using it quite often. Remember, sine theta is Y over R. Cos theta, we know, is X over R. And tan theta is Y over X. So remember, I'm using this question here that if sine 17 was A, so we got A over 1. Now remember, you have the Y value and you have the R value. Now you need to find the X value. Mr. Kumalo has just joined us. Please mute your mic. We're picking up background. You can put your mic on, guys, when you want to ask a question and then switch it off again. I'm quite happy with that. So now this is very important because if we know our definitions, we can apply it. So in a question like this, what's going to happen here is you're going to use Pythagoras and find the third side. So you see your X is missing. So using Pythagoras, I'm going to say X squared is equal to my R squared, which is 1 squared minus the Y squared, which is A squared. So we get X squared, if you work that out, is actually 1 minus A squared. And then to find X, we know it's going to be the plus minus the square root of 1 minus A squared. So we're going to take the positive, and the reason why, because we're in quadrant 1. And if you notice in quadrant 1, the X is actually positive. Now, most students sitting up to grade 12 will go and mess this up, and they think that you can actually find the square root of that, and they will tell us it's 1 minus A. These are unlike terms. You can't find the square root, so you got to leave it in that form. Okay, so don't make that mistake. Now, once you have the three sides, we know the X value, we can put it down here. The X value is root 1 minus A squared. Once you got three sides in a triangle, you can find all the trig ratios because sine, cos, and tan just need X, Y, and R. So if you look at the first question here, it says, what is tan 17? Now, because my diagram is, this angle is 17, I can use the diagram directly. And we know tan, I'm going to write it above that, is a Y over X. So our Y value here in this diagram is A, as you can see. And the X value we just found is actually the root of 1 minus A squared. So that's my first answer for 5.21. Now, I also want to teach you something that we use quite often in grade 12. I'm going to say grade 12 because most of these questions will appear in a grade 12 paper as well, okay? So if you look at the triangle and you think a little bit out of the box here, we can find the third missing angle here. And we can find it using some angles of a triangle. Can someone tell me what will the third angle be? Nobody? Three angles.
73.
Sorry?
73.
Well done. Okay, so we can use some angles of a triangle and we come out with this angle to be 73 degrees. But it's got nothing to do with the question as yet, but it's nice to know that we have an angle called 73 in a diagram. So forget about what I just showed you. And now let's return to the question. The second question here is to find 107. So in my second question, I want to find sine of 107. Now the diagram has 17 and it's got 73. So now you got to remember, try and bring this in 17 because 17 is our reference angle. Only if we're desperate, we'll go to 73. So you'll notice that we're going to use a reduction formula. And if we use a reduction formula, we could go with 180 minus 73. But I want to get a 17. So if you look at a number called 107, we can rewrite 107. We want a 17 basically. So we know to get 107, 90 plus 17 actually gives you 107. So that means I can rewrite this as sine of 90 plus 17. Now, as soon as you say 90 plus theta, you got to remember, we're now going to use our co-ratios. So immediately your sine will change to cos. But before I did that, if I look at where is 90 plus 17, it's actually quadrant 2. And remember, in quadrant 2, we look at what the original question is. Sine is still positive. So therefore, I can go with positive cos 17. Now, as soon as I got 17, I have permission to use the diagram because that angle reference there is 17. So now I can use the diagram. And remember, cos is actually x over r. Going to your diagram, and you can see from your diagram that the x value is root of 1 minus a squared, and the r value is 1. And we can rewrite that as a square root of 1 minus a squared. We don't have to say over 1 because any number divided by 1 is the same thing. Okay, so that's quite interesting. And the question gets a little bit deeper now. So the next question wants to know from us, we want to find, and I'm going to draw a line here just to create some separation. We want to get cos of 253 plus, sorry, cos squared, sine squared 557. Now, you know, from reduction formula, any angle above 360. So you see this is above, we're getting one cycle. Anything above 360, you just subtract 360. So take your calculators out. Take 557 minus 360. Can someone give me a beautiful answer there?
197.
197. So we can rewrite that without even showing any working, straight from your question paper. So we got 557, and I said anything above 360, just take away the 360. Can we put our mic back off there? Mute your mic quickly. Thank you. All right. So can someone confirm that? We said that was 197. Are we all happy with that? So remember, what is my goal? My goal is try to get a 17 in there, because if I get 17, I have permission to use the diagram. So that is our key in getting 17. Now, if we look at the first, the angle called 253, let's write down 253. Can I express this with a 17? It's quite a toughie, you might say. So whenever you're confused, you got to think about your cast diagram. In which quadrant is 253? Anybody knows? Let me quickly.
Third.
In which quadrant is 253?
Isn't it 3 or 4, sir?
Sorry? Sorry, I muted at first. In which
Three,
quadrant
sir.
is 253?
3. The third quadrant, sir.
Third quadrant. How did you get third quadrant? So I'm very worried if you're telling me third quadrant. So let's get back to the quadrants. Remember when I started the lesson? Those of you joined late, I showed this diagram. That's 0, that's 90, that's 180, that's 270. All right? And you'll notice that the young man said third quadrant, and he's now thinking, why did I challenge his understanding? So let's look at it. Is he right or is he wrong? 253 will lie in quadrant 3. Totally correct. Now, what is the reduction formula for quadrant 3? That's a 180 plus theta. So we can rewrite 253 as a 180 plus 73. Now, I'm quite happy to use 73 because can you see I have it in my diagram? Okay, so that's the key. So let's rewrite the first one. So we're going to say cos squared, and we're going to write 253 as 180 plus 73. Now remember, we said we're in quadrant 3, but we're not interested in whether it's positive or negative, because anything squared will give us a positive. So this will turn, using reduction formula, to cos squared 73. Now, From there, we want 17. You can use 73. But remember, if I use 73, I need to use so-called 2 because then my X and Y will change. So I want to be safe and stay with my 17. So we know that 90 minus 17. Now, let me teach this very quickly for you guys who are joining me a little late. Okay, I touched on this in the beginning. Sine and cos are complementary angles. So if you got sine of 40 degrees, the complement of 40 is 90 minus 40, giving you 50. So sine of 40 is actually cos of 50. So can you see your 90 minus 50 is 40, or 90 minus 40. So those are complement angles. So if we got 73, if we got cos 73, so we know the complement of 73 is 17, but we're using co-ratio, so cos becomes sine. Now that's what we're going to use in this question. So I'm going to use my complement angles just to be safe and bring it to 17. So this becomes now sine squared 17 degrees. Okay, don't worry whether it's positive or negative because its square will always be positive. Now let's go and work with the 197. So in the same way, if we now look at 197, and I need to say in which quadrant is 197, and once again, it's sitting in quadrant 3 because it's between 180 and 270. And the angle formula for reduction formula in quadrant 3 is 180 plus theta. So to get 197 plus minus 180 is 17. So we can write sine squared 197 would become 180 plus 17. So our next step that will change to using reduction formula, and we're not interested in the sine because it's squared. Anything squared will be positive. So we can get sine squared 17. Okay, and I'm going to bring that down to be sine squared 17. Now, sine squared 17 plus sine squared 17 is it's like saying we have two like terms. X plus x is 2x, so we're going to get 2 sine squared 17. But I have permission to use my diagram because it's 17. Can you see that? And remember, we know that sine is y over r. So if I look at my diagram, my y value according to me is a, as you can see. So I'm going to put it in here. And my r value is 1, a over 1. In other words, it's a, and that was also given if we lost. That sine 17 is actually a. So I didn't have to use my diagram. It's given information. A over 1 is a, which gives me 2a. It's quite an interesting question to deal with. And that's what happens in the paper. You know, we're going to get one of each type. So you're going to get one question like this, where an angle is going to be given. I'm just admitting someone else in. Where an angle is going to be given like 17, you can use your construct your triangle like what I did. Find your missing side using Pythagoras. And then what you're going to do to all the angles is like your 107, 557. Using reduction formula, you've got to try and bring it back to 17. Any questions on that one before I move on?
So basically what we're trying to do, sir, is to get them all back to the 17, sir. So we
That's
can put
it.
into the formula.
Because that's what's given. See your diagram? I drew the diagram with
Yes,
17. So to be able to use the values X, Y, and R, I've got to have an angle 17. If it's not 17, you can't use the diagram. Does that make sense to you?
Oh, yes, sir. So we're only going to start doing the question when we've got the basis down to 17, sir. The
Yeah.
rest is we're just trying to get to the 17 first.
Yeah, what you want to do, you know, what you really want to do in a question like that, I just want to find a blank page for you very quickly. You see in a question like that, let's take if they gave us cos, say 15 is equal to m. And that's your information now, all right? So what you want to do in step 1 is to quickly draw a triangle. And we know it's in the first quadrant because 15 is an acute. And put your 15 here. So you want to find the missing side. They will give you always, they will give you two sides. Now, if you look at cos 15, you got to remember, as a fraction, m is written as m over 1. You got to remember that cos is x over r. So immediately you got two sides. Your x value is m. Your r value is 1. But what is missing in this diagram? The y value. So we're going to use Pythagoras. And once you have Pythagoras, you got y squared is equal to, using Pythagoras, you're going to end up with 1 minus x squared. All right. And to find y, you're going to say that's the square root of 1 minus x squared. So can you see now I have x is m, r is 1, and my y value is the square root of 1 minus x squared. So I can now use this diagram condition that the angle is 15. So they might give you a question like, all right, first question would be like, say, find sine 15. So because it's 15, you can use your diagram and say, okay, sine 15 has to be y over r. We found our y value, roots over the r value, which is 1. That's a simple question. But then they're going to complicate your life and say, okay, right, now go and find tan of, let's say, 195. Now you can't use the diagram because the angle, there's no 195. So now you want to rewrite this using your reduction formula. 195, if you think now it's in quadrant 3. Angle formula in quadrant 3 is 180 plus theta. So we're going to rewrite the 195 with a 180 plus 15. Now in quadrant 3, tan is positive. So we convert tan 15. And now we have permission to use the diagram because it is 15 degrees. And that gives you a y. You're going to use y over x because that's 10. And you put your y value over your r. Sorry, I'm using my diagram because it was m, we shouldn't be saying 1 minus x squared, we should be saying 1 minus m squared. Is that making sense?
Yes,
Okay, because
so
let me just put that down.
So with the negative, so do you only put them if there's no squares on them? So
Yes, because you're just wasting time, you know. So that should be an
okay,
m because the x value is m. We can replace the x value with m. So wherever I got a x, we now know that's your m value. Is that making sense to you?
yes, sir. Yes, sir. Yes, it is, sir.
So can you see your x value is m, your y value is the root of 1 minus m squared. So it means I can find any trig ratio. The catchy ones are where you have to bring in co-ratio. Like they may give you, okay, in a question like this, they may talk about, can you find sine of 75? Now, to get 15, we know 90 minus 15 is 75. But remember now we're using co-ratios. So that becomes cos 15 because 90 minus 75 is 15. And once you got cos 15, you now have permission to use the diagram. Cos is x, your x value is m over your r value, which is 1. Okay, which was given as well. So that is your kind of thinking behind a question like that. All right, so that was quite an interesting question. So we're gonna go to, I'm just looking at varieties, okay? So that was a little bit of a diagram question. And you're not allowed to use calculators at this stage on these questions where they say diagrams, okay? So look at the mark schemes, and these are all past paper questions. And they're quite easy to score marks once you understand the reduction formula. Look at this question here, it's a 7-mark question, all right? And you're going to use, in a question like this, a reduction formula. So let's get our thinking right. So if we go back, and I think it's important to come back to this point now. Sorry, let me just. Sorry,
sir.
Yes.
Could you please go back to 5.2.3, sir? You know, in the
Yes,
last step there.
5.2.3.
Yes, sir. What you see there, it's 2 sine squared 17. What do you do with the square, sir?
Yeah, sorry. Thanks for bringing. I actually forgot to bring in the square. See how important it is for you guys to pay attention. That square is still there, so that should be a 2a squared.
Okay, sir.
Yeah, thanks for that. Mr. Finney's on top form there. So guys, we got our thinking right. I want the thinking to kind of be how you're going to handle a question like this. You see, you need a strategy. That is very important. When you're going to write the paper, you're going to have, you're going to see a question like this. You need to know where to start. And are we all feeling comfortable that sine 7 is equal to a? Where are we going to start? We get a diagram going.
So I'd just like to ask, sir, why is R equal to 1?
Very good question. Who would like to respond to that, young man, before I respond? Nobody? Somebody? Who would like to tell him why is R1? All right, put your mic down. We're picking up too much of background. Okay, some of you have a lot of people talking in the background. I don't blame them. It's the evening, so I'm not blaming you. But just be a little bit considerate. If there's a lot of people talking, try not to put your mic on because we're picking up a lot of feedback on this end. And I am recording the lesson, so it's going to pick up on a recording. Okay. All right.
So
I had a question here, and I want
definition, sir.
Sorry. Somebody asked me a question, and I haven't given an answer, so I just want to erase my. Just want to quickly erase this. Okay. Okay. Let's understand this again. All right. One more I'm going to do, then I think we must move on. So let's take a question like this. 10, 20 is equal to a letter called P. All right. Now remember, sine, cos, and tan, they are ratios. Sine is y over r, so they are all ratios. So we want to express this as a fraction. And the way you express what is P as a fraction, every number can be, all rational numbers can be written as fractions. In other words, how do you write 5 as a fraction? How would you write 5 as a fraction?
5 over 1, sir.
5 over 1. We got a fraction. So the first thing we want to do is express this as a fraction. So all you have to do is put it over 1. And the reason is because tan actually means y over x. So now we can relate this to tan. Because remember, I want to draw a diagram. And these actually represent the sides in a triangle. And according to this question, now we're saying, okay, the y value is p. The x value is 1. And to find r, we got to use Pythagoras. Okay? And it will be 1 squared. Now we use a plus because you're finding radius. And that gives you a 1 plus p squared. So young man, do you know why I have to put it over 1 now?
Oh, yes, sir. Yes, sir. I understand, sir. Thank you, sir.
Good. Okay. So, do I have permission now to move on? Guys, feel free to stop me if I make a mistake because it is late in the evening now, and I just come out of load shedding, to be honest. So sometimes, you know, I may do an additional. So please feel free to butt in and tell me, okay, we forgot to, like in the last question, do the square on it. All right. Now, what we need to understand in a question like this is very important, is the cast diagram. All right. And understanding where the angle goes in a quadrant. That's very important to us. And remember, I told you this is a 7-mark question. And these questions are famous to come out. And they'll come out for like, just one of it is going to come out for like 7 marks. So we must be able to get the thinking right because it's easy marks. So remember, when you get your question paper, draw this. That's a 0. That's our 90. That's our 180. That's our 270. And that is returning to 360. We know everything in quadrant 1 is theta. In other words, it's an accurate angle. But in quadrant 2, we want a 180 minus. In quadrant 3, we want a 180 plus. And in quadrant 4, it has to be a 360 minus. We won't use co-ratios. Co-ratios is our last option. Because with co-ratios, we have to change sine to cos or cos to sine. So we try not to use co-ratios. Okay, is that making sense to you? So that's quadrant 1, 2, 3, and 4. So I'm going to tackle this question now and teach you how to actually think here on this one. So the first one is 120. So if you got 120, you got to say, which quadrant is 120 in? And immediately you'll be able to tell me, all right, 120 is in quadrant 2 because it's between 90 and 180. So immediately I can go write the sign. Because I'm in quadrant 2, it's a 180 minus theta. Now we want to bring it to an accurate angle. So what is 180 minus 120? 60. Now check. 180 minus 60 is 120. So we rewrote 120 as the reduction formula, 180 minus 60, which is quite simple. Then we go to the next one. And the next one you see is 210. So in which quadrant is 210? So 210 is lying between 180 and 270. So there's my 210 there in quadrant 3. So for that one, I'm going to use cos. Quadrant 3, the angle formula is 180 plus. Now I want to get 210. It has to be 210 minus 180 is 30. And check. 180 plus 30 is 210. So I'm covered. I go to the next one called 315. And if you look at 315, it's actually sitting now in quadrant 4. And if I'm in quadrant 4, my angle formula is 360 minus. So I'm going to rewrite that as 10. And I want to use 360 minus. And we want to get 315. So 360 working backwards. You can use your calculator. 360 minus 315 is 45 degrees. And I'm running short of space, as you can see. So I'm going to quickly get my eraser out. And then I can put this back on. The last one is cos 27. Now, 27 is an accurate angle. It's less than 90. Keep it for now as it is. We'll deal with it later. Okay, I want to get my eraser back out. So we kind of sorted the numerator out. Now that's all over. Let's go now to the denominator. So if we look at the denominator, the first one is sine 63. For now, I'm going to leave it as it is because it's an accurate angle. And then you got 540. Anything above 360, what you can do is just take your calculator out, subtract 360. And what is 540 minus 360? Anyone got an answer for me?
180.
Well done. Okay. So we got 180. So I'm going to rewrite this as cos 180. So from here, now starts the application of what we call the reduction formula. Okay, so if we look at the first one that we have, 180 minus 60, we said that's quadrant 2. And in quadrant 2, returning to my cast diagram, and I'm going to just write this down very quickly for those of you who missed the opening session. CAST. I'm sure you know what that stands for. So if we go into quadrant 2, all right, and this is my quadrant 2, S for sine, it's not clear. That means sine is positive. So in quadrant 2, we will rewrite this reduction formula. It is going to be positive sine, and we bring down the acute angle of 60 times. We go to 180 plus 30. 180 plus 30 is in quadrant 3. And if we go to quadrant 3, cos is negative. Only tan is positive. So that should be changing to a minus cos 30. So we now go to the next one. 360 minus 45. That's your fourth quadrant. And 10 is negative in the fourth quadrant. So that becomes minus 10 of the acute angle called 45. And then we got a cos 27 to bring down. We go to the bottom, we got sine 63. We're going to bring that down for now. And then we got cos 180. Now I'm going to talk about special angles, all right? You're allowed to use your calculator, although it says no calculator. You know, your teacher would have taught you via triangles or looking at a table, how to pull out the special angles. So our special angles are 30, 45, and 60. So remember that. Let's make a note that they're all our special angles. That means we can use a calculator, 30, 45, 60. And also 0 and multiples of 90. That means 90, 180. You can actually use your graph as well to work this out, but we don't have time for the graph, etc. So we're going to go straight into this. Now, I'm hoping you got the calculators here with you. Does everyone have the calculator? Yes or no?
Sorry, sir.
Yes.
What happened to the cos 180 at the bottom?
Right, I'm going to bring that in, all right? Can you see that cos 180?
Yes, sir.
Right, we got to bring that down because I haven't changed it as yet.
Okay.
Now, let's
Okay,
start
thank
with
you.
a calculator. Someone take out the calculators, actually, as many of you, so we have confirmation. The first thing we want to type, what is cos 60? So not cos 60, sine 60. What is sine 60?
It's 3/2.
Well done. We got a root 3 over 2. Thank you. Now, a negative times a negative. Let's sort that problem out, all right? A negative times a negative is a positive. Or if you're not sure, just bring in your negative. We'll deal with it later. Type in cos 30. What did you get for cos 30?
Negative square root 3/2 again, sir.
Now, so we go. Mics off, please. Mics off. Now, if we go to the next one, minus 1045. What is 1045? 1.
1, sir.
All right. Now, we got cos 27, which is not a special angle. So I'm just bringing it down for now, all right? And then we got, come to the bottom, we got sine 63, which is not a special angle. But now let's deal with cos 180. Type it in your calculator. What is cos 180?
-1, sir.
Negative 1. Now, before we go on, so we want to look at, well, we got all the measurements in terms of numbers. It's very easy, except we're a little bit annoyed with one thing there in the question, all right? That the cos 27 and 63. But if you work out 27 plus 63 is 90 degrees. So those are co-ratios. In other words, I can rewrite 63 as a 27 because I'm using 90 minus. So 90 minus 63, your sign will change to cos. So we can rewrite sine 63 as cos 27, which will now allow us to cancel that off. Does that make sense to you? Now, carrying on with the problem. Well, you can see we have a -1 that can cancel off very nicely as well. And then we're ready to multiply the top. Now, everything in the denominator is out. We just have our numerator. So root 3 times, sorry, we have a negative. Positive times negative is negative. And a root 3 times a root 3 is 3. And 2 times 2 is 4. So we got a -3 over 4. Are we understanding this question for 7 marks? Yes or no?
So,
Yes.
I don't understand why the sine 63 turned into cos 27.
Co-ratios. You know, I taught you about a little bit of earlier about co-ratios, and this is what co-ratios mean. So if you take an angle as sine 40, the co actually means a complement. You did complementary angles in your younger form. A complement means it adds up to 90. So the complement of 40 is what? 50. 90 minus 40 is 50. But as soon as you use a complement, your sign will change to the co-ratio. The co-ratio of sine is what? Cos. So we had 27 or 63. All right. And I think it was sine 63. So the co-ratio of 63, 90 minus 63 is 27. And I'm using a co-ratio, so the sign must change to cos. Okay, so we're using a concept called, have you done co-ratios in class?
Oh, yes, I understand now, sir. Thank you, sir.
Okay, now,
So when do you know when to use the co-ratio?
well, that's a good point. When do we know? Can you see? The question said no calculators. So that means you have to bring all the angles to special angles. There's all your special angles. Can you see that? 30, 45, 60, 0, 90. So we had a 27 and a 63. They're not special angles. So that means I'm trying to cancel them off. So what is coming? My next option is how can I relate 27 and 63? And if you actually add 27 and 63, it gives you 90. So it means use your co-ratios. Okay, I want to go to another question. I'll come back to number one just now. So maybe that'll help before we come back to numbers. Let's look at a question like this. Can everyone see that? So another 7-mark question. So you're going to work with me with this one. Are you guys happy to work with me? All right. So in this question, we're using reduction formula, as you can see. So the first one, sine 90 minus. As soon as you see 90 minus, it means 90 minus, get it in your brain, indoctrinate yourself. 90 minus 90 plus means use a co-ratio. So immediately we see 90 minus the sign. We are in quadrant 1. Everything is positive in quadrant 1. 90 minus is quadrant 1. So sign will change to cos x. There's your first mark. Are you happy with that? How I change it? So we got a 180 minus x. That is quadrant 2. In quadrant 2, cos is negative. So that becomes a minus cos x. Now we got a plus sign, write it big. Because you don't want to confuse them. These are like two different terms here. So tan x. Now, whenever you see tan, the best thing to do is tan. Remember the formula says that tan is actually sine over cos. So we'll be able to cancel something off sooner or later. Now, whenever you see a negative angle, the rule is add 360. So if we look at what is 360 minus x, which means we are in the fourth quadrant, and cos is positive in your fourth quadrant. So I'm going to put a bracket here now. That actually will become cos x. And because I got fractions, let's write this as a fraction, cos x over 1. Okay, so it'll cancel off immediately. Can you see how nicely that one, this and this cancels off? And then we got a sine 180 plus x. That's now third quadrant. And we know in the third quadrant, sine is negative. Are you digesting that?
Yes,
Now,
sir.
we look at this part. A positive times negative is negative, so we're going to end up with a minus cos squared x. And on this side, we've got a positive times a negative, which is also a minus. And sine times sine is sine squared x. Now, I know there's a grade 11 formula that says that sine squared plus cos squared equal to 1. But I got a minus and a minus. So what I'm going to do is take out a minus. Just hold on. So if you take out a minus there, gentlemen, we're now going to end up with cos squared x plus sine squared x, because I took out a minus, and the minus sign will change your signs in the bracket. And we know that cos squared plus sine squared is 1. So that turns out to be a negative 1.
Oh, sorry, sir. I got a question, sir.
Go for it.
Sir, with the cos minus x, how's it 360, sir?
That's a negative angle. So remember the rule, whenever you have a negative angle, you'll add 360. Because actually, mathematically, what we're actually doing, when we say negative, we normally go this way with our quadrants, all right, in an anti-clockwise. So there's our positive direction. As soon as you say negative, we're actually moving the other way, which means immediately
Yes,
I'm
sir.
sitting in the fourth quadrant. And what is the angle formula? 360 minus x. But a simple rule is add 360 when you see a negative angle.
Also, we bring it back to quadrant 1, sir.
We're saying that cos of negative x means we actually in the first quadrant going backwards. And the first quadrant going clockward is actually quadrant 4, which is an angle formula of 360 minus x. Okay, so whenever you see cos of minus x, remember you're going to say this is fourth quadrant, 360 minus x, because you're going in the opposite direction.
Oh, okay. Thanks, sir.
Okay, let's just move on, get more practice. So let's take this question here. I'd like you to work it out, try it out first. Let's give you about, I'm going to give you maybe 2 minutes to try out. I'm just going to pause the recording while you're trying this out. All right, I'm going to carry on. Doesn't matter if you're not finished because of time. So if we look at the question at hand, the thinking process is, all right, 360 minus x fourth quadrant. So that will change to negative because in the fourth quadrant sign is negative. That becomes a minus sign x. Then we've got tan of negative x. Remember I spoke about this negative angle. You can add 360. Or you could note that minus x means we are actually going backwards, which means we're in the fourth quadrant. And in the fourth quadrant, tan is negative. Going on the other side, 180 plus x, third quadrant. In the third quadrant, cos is also negative. Now we got sine squared a plus cos squared a, and that's a simple formula, which means that is actually 1. So working with this, remember that we now have a minus sine x and a minus cos x. We can actually cancel that off. A negative and a negative can cancel off for us. So we got sine x all over cos x. And remember that tan is actually sine x over cos x. Or we could have went the other way and said, all right, you know what? The easy way to look at this is, okay, we can carry on with this and just say, all right, this is actually sine squared x over cos squared x, which is the same thing as saying sine x over cos x is tan x and all squared. Or you could have went this route. The easier route, I think, with this one, and maybe some of you would have went this route. So I'm going to go back and show you the other route, is that you could have said sine x over cos x is actually tan x. All right. Sorry, I missed out the minus here. I should have kept my minus. All right. And that becomes a negative tan x squared. And then on the other side here, we have sine x over cos x is tan x. And you got a minus tan x, which makes that minus, keeping our negative. And that actually gives us a minus tan squared x. So both ways, we will get the same answer. Did you manage to get that?
Yes, sir. Yes, sir.
Okay, so that's quite good if you're getting it, all right? So,
Sorry, sir.
yes.
Could you please explain the sine squared A plus cos squared A? So how you got 1 from that?
That's a formula. Okay, so there's a formula that you got to learn. Sine squared x plus cos squared x. It is a formula. It's 1. You got to just memorize that. And there's 2 formulas we need to know in grade 11, which will not be on the formula page. All right. So you need to learn that one off. Is that making sense to you? Tan x is sine
Yes.
x over cos x, and sine squared x plus cos squared x is 1. I think you guys joined us a little late. So we spoke about in the beginning. And then I just want to tell you one thing, because you weren't here in the beginning, that if you look at the sine squared x, now write it down and memorize it. It's going to help you a lot. You must memorize this. Sine squared x, if we take the cos on the other side, we can say sine squared is 1 minus cos squared x. Or if we start with a cos squared x, and we take the sine squared on the other side, we'll give you a 1 minus sine squared x. So these 4 formulas, you need to memorize. Okay, does that answer your question where I got it from?
Yes, sir. Thank you, sir.
Gentlemen, I want to move a little faster because I'm just looking at the time now. It's 7:20. We're stopping at 8 o'clock. So I want to get a little faster, or we're going to be in trouble. All right. Okay, so let's look at the next one. It's called a question that must appear in the paper is on trig identities. So where we say, right, prove this. So you look at the first one, you start on your right-hand side, RHS. You can start any side, to be honest. So we don't have to rewrite the question, but this is the right-hand side, as you can see. Okay. So if we look at our right-hand side, so if you quickly look at that, and you're trying to say, is there any formulas there that I can use? So on the top, actually not. So let's write down our sine x cos x. But if you look at the bottom, can you see a formula there? Did anyone spot it? We just spoke about that. So
Yes,
what
sir.
is 1 minus sine squared?
Cos squared.
See? So we can replace 1 minus sine squared x with cos squared x. And then there's a plus cos squared x. So remember that I think it was Finney asked me the question. I told you we got to memorize this formula. Sine squared x plus cos squared x is actually equal to 1. So if we make cos squared x the subject of the formula, it's actually 1 minus sine squared x. So I'm now replacing the 1 minus sine squared with cos squared. And if we carry on, so we got sine x, cos x. Now we got cos squared x plus cos squared x. That's like saying 1 apple plus 1 apple is 2 apples. And that gives us 2 cos squared x. Now, we can now cancel. Cos squared x in the bottom means cos x times cos x. So we can cancel that with the square. And then we just left with a cos x in the bottom. Let's rewrite this. If I rewrite that, sorry. So I'm going to erase that quickly. Messed up my page a little there. Okay. So if we rewrite this, we're actually saying we have a sine x on the top. And in the bottom, we have a cos x. And we know that's tan x. But in the bottom, we also have a 2. And the number in front of sine x, which is hidden for us, is 1. Okay. There's always a 1 in front. When you say I ate a apple, it means you ate 1. If you ate 2, you'll say 2. So remember, there's always a 1 in front. So we know from here, the number is 1 over 2, which is half. Let's separate it. And sine x over cos x is actually tan x. And if you look on the sorry, I should have said starting with the left-hand side, not right-hand side. And that is actually equal to the right-hand side. So we proved the trig identity. Are you happy with that?
Yes, sir.
The chances of actually having to
Yes, sir.
work out the right hand side and then do the left hand side. So
Yeah, you're starting with you can start any side you want to. Take the one where you can actually simplify. and then you want to get the other side. So this is called a trig identity. Okay, let's do one more. Okay. So we see the left-hand side. We're going to start again with our left-hand side. Now, I also want to teach you this formula that you already know. Okay. So if tan x is equal to sine x over cos x, if you flip it, that means you say 1 over tan x. Sorry, my pen is getting a little rude here. It's going off a tangent at times. So if we flip this 1 over tan x, you actually flip the right hand side, and 1 over tan x will be cos x over sine x. It's quite handy to know. Is that making sense to you? So if we looked at our left hand side, so we have 1 over tan squared x. So 1 over tan x is cos x over sine x. So 1 over tan squared would be cos squared x over sine squared x. So these rules that I'm teaching you, you got to memorize them. And then you got a minus cos squared x. So I took the left-hand side. And now I want to try and get it to look like the right-hand side. Now immediately you see you have a denominator. So we want to write the other cos squared x as with a denominator. So we put it over 1. So we find an LCD. What is our LCD here? Our LCD is sine squared x.
Sine squared, sir.
So we need to multiply this side by sine squared x, and the golden rule on fractions, what you do on the bottom, you will do on the top. So now we end up with, in the bottom, we have our LCD, which is sine squared x. And on the top, I have cos squared x, agreed, minus, and on the top, I have cos squared x times sine squared x. Now, remember, I haven't reached my destination. I'm trying to get to my right-hand side. Look at what the right-hand side looks like. So now if I look at the top, and what is striking me is that there is a common factor there. If you look at your two terms, cos squared x is common. So we're going to pull it out as a common factor, and we're left with 1 minus sine squared x. And if you look a little closer, 1 minus sine squared x is a formula. And if you remember a little early on, 1 minus sine squared x, that's our formula that can be replaced with cos squared x. And all over sine squared x. So we got cos squared times cos squared will actually give you cos to the power 4x. All over sine squared x. And if you quickly peek now at your right-hand side, that's actually what we wanted to prove. Guys, you might just have to screenshot some of this because of time, right? And you can go through it again. Just to digest it. Oh, actually, I have a recording. Don't stress. I'm going to put the recording up. Okay, so I'll come back to some identities a little later.
Sorry, sir.
Yes.
So that question, sir, in the beginning, why couldn't you just cancel, sir? The cause here, so these two.
Because there's a minus sign in between. You can only cancel if it's a
Oh.
multiplication.
Okay, sir.
Okay. There's a minus sign in between. So we got to find an LCD. Remember addition and subtraction of fractions, you find an LCD. Make the denominators the same. On multiplication and division, we can do our canceling tricks. Okay, another very important section in the paper is what we call trig equations. Have you done trig equations? Yes or no?
Yes, sir.
All right.
Yes, sir.
Okay, so simple. If you take the first question I have there on trig equations, it's very simple. All right, these are the rules to trig equations. And you have 10x plus 10 equal to 8.5. So the first thing is you want to keep 10 on the left-hand side alone. So taking your calculator, you'll say 8.5 take your 10 on that side, becomes a minus 10. And then we end up with 10x to be equal to a negative 1.55. Calculators out, please. So the rules on trig equations is firstly, we want to isolate the trig ratio called 10. Now, the negative means I need to check in which quadrant is 10 negative. And 10 is negative in quadrant 2 and 4, which is a 180 minus theta and a 360 minus. Okay. So our next step is to come out with a reference angle. Now, to get your reference angle out, you need to say the only way you can get rid of 10. Remember, this whole thing represents the angle x. But the only way you can get rid of 10 is to shift it. In other words, use your shift key. But when you're getting a reference angle, you don't type in negative. Your negative is to determine which quad. So you'll type shift 10 1.55. Can everyone type in shift 10 1.55? Nobody? Somebody? Give me an answer.
57,17, sir.
2 decimal places. 57,
17, sir.
can someone confirm that?
Yes, sir.
All right.
Yes, sir.
Okay. So we have our reference angle. Sorry.
17, sir.
17. Is that correct?
Yes, sir.
Okay. Now remember what we said about a negative. The negative, we said it's going to lie in quadrant 2 and 4. So if we think about quadrant 2, now the angle is x. So x will be equal to, in quadrant 2, it will be 180 minus the reference angle. Theta now is represented by the reference. So I'm going to write here reference. So 180 minus 57.17 plus 360K. Now take your calculator out. And as soon as you bring in K, you need to make a statement that K is an element of Z. So we now have X would be 180 minus 57.17. And if we take 180, what do we get?
122,83,
122, comma,
83 degrees.
83. Now, we also need to look at this in a fourth quadrant, but this is a 10, and if you know the 10 graph, this is a 10 graph. The period of a 10 graph is 180. So with a 10 graph, we can get away. We don't have to look at 2 quadrants for the 10 graph. We can just say, all right, a 180K, because a 10 graph will repeat itself after every 180. You know your 10 graph, the period is 180. So we could get away with the 10 graph. And that will be our answer. We don't have to check for the other quadrant. But if you were sitting with sine and cos, you will have to check, because the period on sine and cos is 360. Is that making sense what I'm saying about a 10 graph? Yes or no?
Yes, sir.
Okay.
Yes, sir.
So we'll
Yes,
take
sir.
one,
Yes, sir.
we're gonna take one now, where we're not going to use the we're not going to use 10, and I'm going to show you the difference. So remember, for 10, you can get away with saying 180K because it repeats itself after every 180. That's your period. So let's look at the next question. Okay. So if we look at the next question, give you some time to get started while I'm rubbing my board. So remember I said we want to isolate the cost. So there's a number in front of 2. So to get rid of that number in front of 2, we'll divide both sides by 2. So we're going to get cos 2x. Actually, let me put a 2 here in front. 2x minus 10 is equal to 1.3 over 2. Now, do you know why I did that? Everyone with me?
Yes, sir.
Now, Mistake with most grade 11s. I don't teach grade 11s. You know, I teach grade 12s at the school. But your biggest mistake is people want to separate this. In other words, they want to take the minus 10 on that side and make it positive 10. Or they want to divide this 2x by 2. You cannot, because there's a cost in front of it. So it's married to the cost. You can't move the 2x. You can't divide by 2. You can't move the minus 10. Your first thing is you must get rid of cost. Okay, so remember, think of it, cost is married to 2x minus 10. The only way you can get rid of cost is to shift it. In other words, use your shift key. So our journey continues. We want to find the reference angle. Now, before we find a reference angle, you notice that it's positive. Look at your right-hand side, it's saying positive. In which quadrant is cost positive? Cost is positive in quadrant 1 and quadrant 4.
For
Now, in
sure.
quadrant 1, the angle is theta. It's an accurate angle, no problems. In quadrant 4, it's 360 minus theta. In this case, we're going to say reference. Now, calculators out. Shift cost. There's only one way you can get rid of the cost, to use your shift key. Shift cost. Use your fraction button, 1.3 over 2. Give me an answer.
49.46 degrees.
Sorry, say that again.
49,
Oh, 49.
comma,
Can someone
wait,
confirm
I'll
that?
say it.
Can
So
someone?
it's 49,546.
He's right.
49,46.
Thank you. 49,46. Are we all happy with that answer?
Yes, sir.
Now,
Yes, sir.
remember
Yes,
what
sir.
next to it represents the whole angle. So that is now the whole angle. Before we said x. So we have two options. In quadrant 1, we don't have an issue. In quadrant 1, the angle now x is represented by 2x minus 10. That's your entire angle, is equal to the reference angle in quadrant 1, 49.46. It's an accurate angle. But because they said general solution, you want to add 360k. And remember, as soon as we bring in k, we're going to say k is the element of z. Now that is in quadrant 1. But we know that cost is also positive in quadrant 4. So in quadrant 4, it's going to be 2x minus 10 is equal to 360. The angle formula in quadrant 4 is 360 minus the 49.46 plus 360k. Now we finish say k is the element of z, so we don't have to write it again. Now, calculators out. Let's go to the first one. Now we're not going to waste time. We're going to take the minus 10 on that side. It's going to become plus 10. So that changes to 59.46 plus 360k. Calculators out. We're going to divide right through by 2 to find x. Can someone take 59.46 and divide by 2 for me?
29,73, sir.
And we also divide the 360 by 2. So there's our first answer. I'm underlining it so you can see that is the answer. That is the answer. Now we go to the quadrant 4. So 2x in this case would be equal to, we're going to take our minus 10 on that side. But before we take it there, on a calculator, you're going to say 360 minus 49.46, and then the minus 10 becomes a plus 10. Can someone work that out? 360 minus 49.46 and add 10 to that.
$320.54, sir.
300 and?
20.54, sir.
Can someone confirm that, please?
Yes, sir. Yes, sir.
Okay, so that's what we're going to get. Now we're going to take this and divide it by 2. Calculators out. 320.54.
Wait, sir.
Yes.
Sir,
Yes.
for question 5.22, sir, if we look at the 10 there, it's to the power of 0, sir. Wouldn't
That's
that be
not-
1 then?
No, that's not power 0. That's a degree sign. We're working with angles. That's 10 degrees.
Okay.
Okay.
Okay, then you sir.
Now let's divide that by 2. So we should be getting 160.27. Am I right?
Yes, sir. Yes, sir.
Plus 180. Okay. So this is our general solution. Yes or no?
Yes, sir.
Okay, so can you see what we're doing? What is our aim here? Our aim is to isolate cos and then find the reference angle. But before we find the reference angle, we got to determine in which quadrants are we looking. And cos in this case was positive in quadrant 1 and 4. So we find our reference angle and then work with quadrant 1 and quadrant 4, and we solve for x. Are you all happy
Sorry,
with that?
sir.
Yes.
Sorry, sir. If cos was negative, so you would look for the quadrants where cos is negative, sir.
Yes. If we had a minus 1.3 over 2, then our solutions will now lie in quadrant 2 and 3. So we're going to use 180
Okay.
minus and 180 plus.
Okay, sir. Thanks, sir.
Okay, so we'll come back to more general solutions. I think we should do one more. I like that point there where someone mentioned, what if it was negative? So let's look at a negative scenario. You want to look at a negative scenario? Yes or no?
Yes, sir. Yes, sir.
So I think we should move on, sir.
Sorry?
So I think we should move on because of time.
Yeah, I just want to see the thinking. Right? So we have something like sine of 3x minus, say, 15. And if that was equal to, say, minus 3 over 4. So now you'll ask yourself a question. You're going to find your reference angle. But in which quadrants is it negative? So sine is negative in quadrant 3 and 4. So that's a 180 plus, and that's a 360 minus your reference angle. So when you take your calculator out, you're going to type shift sine 3 over 4. Can someone quickly type that in for me? Shift sine 3 over 4.
$48.59, sir.
48.59.
Sir.
But now remember that it's negative in quadrant 3 and 4. So in quadrant 3, I would say my angle, remember this whole thing now is the angle. So you say 3x minus 15 is equal to 180 plus the reference angle. See, I'm getting it from there, 48.59. And then I'm going to add 360k. K is the element of z. But in quadrant 4, you're going to say 3x minus 15 is equal to, quadrant 4 is now saying 360 minus 48.59 plus your 360k. And from there, you can solve it. So can you see what the negative would have done for us? Make sense? Yes or no? So we're touching a little on all the aspects here, right? So
Yes, sir.
I want you to look at a little bit of sine
Sorry, sir.
in the area. Sorry.
Sorry, I didn't see what the negative did there, sir. Can you please go back quickly, sir?
Yeah. See, the negative is telling us that sine is negative in quadrant 3 and 4. And the angle
Yes, sir.
in quadrant 3 is 180 plus, and the angle formula in quadrant 4 is 360 minus.
Oh, okay, so
So that's what it actually did. It's basically, you're saying 180 plus whatever reference angle you worked out. And here you're saying 360 minus whatever the reference angle is.
oh, okay. Thanks, sir.
Okay, so that is our trig equations. And I'd like to do more, to be honest, but time is moving very fast. Now, there's something called the sine. Guys, did your teachers upload any some documents for you on your Teams group.
Yes, sir.
Okay, so I'll put a document up with the 4 theorems that I have videos on my YouTube channel. One of the 4 theorems must come out. So you got to study the 4 theorems. Are you guys with me?
I'm a bit lost, sir.
Who's your maths teacher?
Mrs. Rambold.
Okay, so I have you can answer on Teams. She'll send you the document, all the video links. So 4 proofs must come out from the theorems. I mean, not 4, 1 out of the 4 will come out, guaranteed, right? So you must learn your proofs. And that is a guaranteed like 6 marks in the paper. All right?
So is this for geo or for trig, sir?
Geometry. This is Monday's paper.
Geometry. Oh, okay. Never mind, sir.
So now, I'm going to go on now. And I want to now actually deal with some 2D questions. So let's take a simple diagram to start off before we go a little deep into this, all right? If you take a right angle triangle, okay, and we are given measurements in this right angle triangle, a very simple illustration. Let's call this 3, and we're going to call this, we don't know it. Are you guys with me? All right, or maybe the radius, let's say call this X. Okay. And let's suppose that this angle here was 40 degrees. So there are 2 ways we could find X. All right. Number 1, we could use SOHCAHTOA. In other words, if we're using SOHCAHTOA and looking from an angle of 30, this will be my adjacent. That's my opposite, but we don't have it. We don't want to find it, so let's leave it out. And the X actually represents your hypotenuse. So we know from trig, SOHCAHTOA. So the adjacent and the hypotenuse is represented with the cos. So I can say cos 40 is actually equal to adjacent, which is 3 over X. And from here, I can go and solve X by cross multiplying. That's a simple illustration. Some people actually use the sine rule on this. And the sine rule works quite simply. You take the side, which is X, over the sine of the angle, and the angle there is 90, which is equal to, and then we're going to take the other side, which is 3, and then the angle opposite that, which we don't have, but remember this is a triangle. 180 minus 90 is 90, 90 minus 40 is 50, so we have 50 degrees there. So we could say that's 3 over sine 50. And that is actually the sine rule, as you can see. And then we can cross multiply. And remember, sine 90, sine 50 can be found in the calculator. So we can find our X using the sine rule. So that is a simple illustration of how we can use sine rule in a right angle triangle, or we could use SOHCAHTOA. So going a little deeper into 2D problems now. And 2D problem basically deals with triangles. So if you take any triangle now, and all we are saying now with the triangles is, if you take this side called X, and let's call this, actually, let's use small sides. Opposite angle A is small a, and opposite angle B is small b, and opposite angle C is small c in references of side. So it works very simply now. If you take A, you're saying A over sine of angle A, as I showed you, and you can decide which side you want to use. So let's suppose I'm using B. So it'll be B over sine of angle B. So that's how we use the sine rule. But it has its limitations, all right? We'll talk about that a little later. So if we look at this question that I want to work with, okay, I want to start off with, where's the question I want to work with now first? Okay, if we look at this question, the question is to find BD. So if we want to find BD in this case, and we're going to use a simple illustration of the sine rule. So we want to find BD. So I'm going to use the red triangle that I'm now highlighting. All right, the red triangle. So we're going to take BD and let's put a dot on BD. It has to be opposite sine of that. So I can say, right, immediately BD over sine of 109.16 has to be equal to. Now, if I'm looking at a red triangle, I'm not going to use AD because I don't have the measurement, but I have the measurement for AB. So that gives me a 90.52. And if I use BD, then I'm going to take it over the angle opposite it, which is sine of 31.23. Now, with my calculators, I can do a cross multiplication. Okay, before we use the calculator, BD, we're going to cross multiply. BD times sine 31.23 has to be equal to 90.52 times sine of 109.16. Okay, whatever your answer is, they keep it on your calculator. And then what we're going to do to find BD, we're going to divide both sides by sine 31.3. Now, we don't want to get a round of error. That's why I said keep your calculators. So what would BD be? So you're going to take sine 109.16 times 90.52, and then you're going to divide by sine 31.23. Can I have an answer for BD? No one's got an answer for me?
So to be honest, I kind of lost you there, sir.
How many of you got lost?
Me too, sir. Me too, sir. I got lost this, sir.
Okay, I'm going to do it one more time for you. I know it's quite so guys, just to let you know what I'm doing now, you know, it's very important for the paper, all the things that I'm doing, because you're writing on Monday. Am I right? Do we all understand that?
Yes, sir.
Yes, sir.
Yes, sir.
So if you don't understand anything I'm doing here, it means you must go back and redo it, because you're going to be in trouble on Monday. Okay, that's just good friendly advice for you. Okay. So at least you got the weekend to study. So we're going to start off. The question says, find BD. We're doing it again. So if I look at BD, I want to use the triangle on the top. And the reason why I'm using a triangle on the top, I have more information on the top. Are you happy why am I using it? So we're going to use a sine rule. The sine rule basically dictates, take the side over the sine of the angle. So what is the side? BD. And that's what we're trying to find, over sine of the angle. And the angle opposite it is actually 109.16. Are you all happy with that? Which is equal to, now I have to use, I'm trying to form an equation. I have to use another side. And the only other side here is given is 90.52. So I'm going to say it's 90.52 over sine of the angle opposite it. And the angle opposite it is actually sine 31.23. That is your sine rule. I want you to digest that. Did you get that point?
Yes, sir. Yes, sir.
Okay.
So we did.
Right. Now, what we're going to do now is cross multiply. So BD times sine 31.23. And then we're going to cross multiply this way, which gives us a 90.52 times sine 109.16. So to find BD, I need to divide. I want to cancel this off. And the only way to cancel this off is to divide by that. Sine 31.23. But it's an equation. Whatever you do on the left, you got to do on the right. And now, if you type that as it is on a calculator, you will get an answer. And that is called the sine rule.